Hello everybody, I can find half-life or irregular time using A equals P, 1 plus or minus R to the T over H. So, in the last lesson we went through our song. We're going to go through our song one more time, and we're going to talk about what everything means. So let's get that going now. Make sure I'm recording. Yeah, sometimes I'm paranoid. One time I did a whole lesson for a half hour. I'm like, oh my god, I wasn't recording. So let's go to Schlansky.com. Let's go to YouTube. Let's go to playlists. And let's go to Common Core Algebra 2 songs. And let's go to modeling exponential functions. Principal parentheses, 1 plus or minus the range to the power of time. 5, 3, by 100, yo. Principal parentheses, 1 plus minus r over n to the power nc. Compound first for continuous. Converting raised 1 over n. Half-life raised t over h. Irregular. Converting raised 1 over n. Half-life raised t over h. Regular. So, let's break this whole song down, and then we'll take a look at today's lesson. So, the first verse. Principal parentheses 1 plus or minus the rates to the power of time. Divide the rate by 100, yo. And that applies to everything. You're dividing the rate by 100. You're always dividing the rate by 100. That's your basic exponential growth decay model. Now, if you see compounding, then we use principal parentheses 1 plus minus r over n to the power nt. For compounding, PERT for continuous. So there's two formulas here. There's PERT if it's compounded continuously, and if it's compounded anything other than continuously, then we use this formula. Converting rates raise 1 over n. We did a lesson on converting rates. We raised to the 1 over n power. There's no real formula for that, but that's a procedure that's very common. And now this is what we're doing for today's lesson. Today's lesson is half-life or irregular time. We're raising to the t over h. So we're going to have our basic simple interests, but instead of to the power of t, we're going to have t over h. And half-life is something that comes up a lot. Half-life is always 1/2, because if it's being cut in half, it's decreasing by 50%. 1 minus 50% is 0.5. 0.5 is a half. So, the half-life formula is the same thing as this formula, but it's just a little bit of a nice shortcut when you have that. So this is for irregular time, and this is half-life. So what do we mean by irregular time? Well, instead of something increasing by 5% every year, it increases by 5% every 3 years. It increases by 5% every 6.4 years. If the time it takes for the percent to be applied is not 1, that's irregular time. That's when we raise to the t over h. That's what today's lesson is going to be. So, again, I can find half-life or irregular time using A equals P, 1 plus or minus the rate to the t over h. That's what's different for irregular time or half-life. The half-life of Mendelevium 258 is 51.5 days. I see half-life, so I'm going to write the formula for half-life. Half-life raised t over h. And since it's half-life, it's always 1/2. Now, there's a little bit of chemistry involved here. If you've taken chemistry or are taking chemistry, you talk about half-life, which measures the rate at which something decays. This 258, this is part of the name of the element. I think it has to do with, I don't know, the electrons or something like that. But it's not A, P, T, or H. It's not a value to substitute in for anything. It's just part of the element, so we're not going to utilize that. So let's list my variables like I've done for all the other lessons in this unit. It's saying the half-life is 51.5 days. So that's H. H is the half-life. It's the time it takes for the percent to be applied. 4,000 is the initial amount, and it wants an equation after D days, so that's going to be D. A is going to be A. So because it's just asking for an equation right now, I'm going to start by writing an equation. A equals 4,000, 1/2 to the D over 51.5. That's an equation to represent the situation. Now, and this will be a 4-point question since it's asking two different questions. It says how much will remain after 12 days. Well, that's T. A lot of students confuse the difference between T and H. T is how much time is actually passing. 12 days have passed. That's what T is. H is the amount of time it takes for the percent to be applied. It's the amount of time it takes for the element to be cut in half. 12 days have passed. That is D. So I get 4,000, 1/2 to the 12 over 51.5 power. I go to my calculator, turn it on, if it ever wants to turn on, which it doesn't apparently. 4,000 1/2 to the power of 12 over 51.5 to the nearest hundredth. That's 3403.43. Did I write that down all right? 3403.43. So for half-life or irregular time, the exponent is T over H instead of just T, where H is the amount of time it takes for the percent to be applied, and that's what half-life is. Half-life is the amount of time it takes to decrease by 50%. So if it's half-life, it's always 1/2 in the parentheses. You're going to see double time and triple time. If it's doubling, it's going to be a 2. If it's tripling, it's going to be a 3. If it's increasing or decreasing by a percent, then it's just going to be 1 plus or minus the rate, which is what we've been doing for quite a while. The amount of ants in a colony doubles every 8 days. So because it's doubling, the difference between doubling and half-life is instead of a half inside the parentheses, it's going to be a 2. So there are let's list my variables, A, P, T, and H. There are initially 275 ants, so my P is going to be 275. It wants an equation for A of T, so I'm going to write A of T, T days, and because it's doubling every 8 days, that means that it takes 8 days for the percent to be applied, in this case the doubling to be applied. That's what H is. It's the amount of time it takes for the rate to be applied. So I'm going to write A of T equals 275, 2 to the power of T over 8. Now the follow-up question, how many ants will be in the colony after 30 days? 30 days is T, that's how much time is passing. So I'm going to do A of 30 equals 275, 2 to the 30 over 8. And I go to my calculator and I type in 275 times 2 to the power of 30 over 8. And to the nearest ant, that would be 3,700 ants. So I think the moral to this story is, if you got an ant problem, you might want to get taken care of it. You might want to get it taken care of right away, because before you know it, you're going to have thousands and thousands of ants. That's how it works. These things grow like crazy. All right, let's move on to number 3. Phil is trying to get himself back in shape and wants to ease his way back into distance running. Good for him. He will start by running 2 miles each day, but every 4 days he will increase his distance by 60%. Every 4 days he's increasing by 60%. That is an irregular amount of time. It's not every day he's increasing by 60%, every week, every month, every year. Every 4 days, that's an irregular amount of time. There's no half, there's no doubling, so I'm just going to write 1 plus or minus the rate to the t over h. A equals P equals R equals T equals H equals. He will start by running 2 miles each day. That's your initial amount. Every 4 days, he increases by 60%. So the rate is 60 divided by 100, which is 0.6. And that rate is being applied every 4 days. So H is 4. H is the amount of time it takes for the rate to be applied. In number 1, it took 51.5 days for it to be cut in half, so H is 51.5. In number 2, it took 8 days for it to double, so that's why H is 8. In number 3, it's taking 4 days to increase by 60%, so that's why H is 4. Create an equation to represent how many miles M he will be running after D days. M equals 2, because he is increasing his distance, it's going to be 1 plus 0.6 to the power of D over 4. You know me, I like to always combine what's inside the parentheses. It's going to make it easier to work with when things get more complicated. This is the answer to my first question. Now, how many miles will Phil be running after 10 days? Well, that's T, or D, I guess we can call it. So I'm going to replace the D with 10 to 1.6 to the power of alpha y equals enter, 10 over 4. To the nearest mile, that is going to be 6 miles. So there's really not much more to it. We can go through another example or two, and then after that, I'm just going to let you practice on your own. The half-life of an element is 27 hours. So I'm just going to start you off for half-life. Half-life raised T over H. And because it's half-life, it's always half inside. So I'm going to ask you at this point to pause it. Try number 4 on your own. Unpause it. At this point, now that you tried number 4 on your own, I will go over it for you. A equals P equals T equals H equals. And again, just like in the previous lesson, we're going to be finding A for all the examples today. And then in the next lesson, we're going to be finding other variables, specifically T. The half-life is 27 hours. It's pretty straightforward. H is 27. That means the amount of time it takes for it to be cut in half is 27. There were initially 4.2 kilograms. That's your P. 2 days, that's your time. A is what we're trying to find. A equals 4.2, 1/2 to the power of T over, oh, I just realized there's a little twist. All right, let me back it up. The units must match. So we have a half-life of 27 hours. Our time is 2 days. They have to be the same unit. So if my half-life is 27 hours, then my time needs to be in hours as well. So since it's 2 days, I would multiply the days by 24 to get 48. This way they're both hours. So my T over H would be 48 over 27. And yes, it does matter which one's on top. The T must be on top, the H must be on the bottom. So again, the gist for not the gist, but the concept for this question, make sure your units match. If this is hours and this is days, make sure that they match. It's easiest in this case to go to hours. Now I can just put the whole thing into the calculator. 4.2 to the power of 1/2. I'm sorry, not to the power of, times 1/2 to the power alpha y equals, enter, 48 over 27. And to the nearest hundredth of a kilogram, that'll be 1.22. I'm thinking maybe just one more. Let's do Java. So I want you to try number 5 on your own right now. So please pause, try number 5 on your own, and then I will go over it. And then after that, you will be able to practice the rest of the period. So again, right now, please pause, try number 5 on your own, and then unpause. Okay, now that you tried number 5 on your own, Jabba went to the movies on Friday night and bought a large popcorn. Good for him. Every 20 minutes, Jabba eats 40% of the remaining amount of popcorn. Not every minute, not every hour, every 20 minutes. That's irregular. Irregular. For irregular and half-life, we raise to the T over H. Now, there's no half-life, there's no doubling. It's decreasing by 40%, so that's why I'm using the 1 plus or minus R. A, P, R, T, H. Every 20 minutes, he eats 40%. So H is the time that it takes for the percent to be applied. 20 minutes is H. After 20 minutes, it is going down by 0.4. And again, to get the 0.4, you can do 40 divided by 100. There were 967 pieces initially. That's your P. Write an equation for A of T to represent the amount of popcorn left after T minutes. So A of T equals 967. The amount of popcorn is decreasing in his bucket. If he's eating it, the amount of popcorn is decreasing. 1 minus 0.4 to the T over 20. And again, I like to always combine what's inside the parentheses. So that's going to be 0.6 to the T over 20. Follow-up question. How many pieces of popcorn will be left an hour and a half into the movie? Well, H is minutes, so I need minutes. How many minutes is an hour and a half? That's 90 minutes. So I'm going to replace T with 90. And I've got 967.6 to the power of 90 over 20. And it wants the nearest piece of popcorn. That would be 97 pieces of popcorn. I think when I made this problem up, I estimated. I have no idea how many pieces of popcorn are a big bucket, but I don't know. Now that I'm looking at it, I feel like 967 pieces of popcorn sounds like a lot. But I don't know. Maybe you should count your popcorn one day when you go to the movies when this pandemic is over. So, if it's an irregular amount of time that the percent is being applied, or half-life, we raise the t over h power instead of just the t power. If it's half-life, then you put a half inside of the parentheses no matter what. If it's doubling, then you put a 2 inside. If it's tripling, you put a 3. If it's increasing or decreasing by a percent, then you're just doing the same 1 plus or minus r that we've been doing for the rest of them. Your classwork/homework is to finish half-life regular time, and then the next lesson we're going to kind of put everything together and also do some algebra to find t, which we'll deal with in the next lesson. Again, your classwork/homework is to finish half-life at regular time, and I hope everybody has a great day.